routing table that we get for directly connected interfaces. So here's an example here. So it's 34.199.5.72. Subnet mask is 255.0.0.0. So we can see here that this is a standard Class A subnet mask. So there are no subnets created here because this is a pure Class A address. So this gives us the actual Class A address here, which is the 34 part. Over here we also have a Class A address, and again we have a standard Class A subnet mask. But look what happens when we subnet. We create subnets now into Class A. So we'll have a look at what that creates in a little minute. So now we have got subnets. So this is within the 34.0.0.0 address space, and we now have a subnet created, of which this part is the subnet, and the device knows about it because it's actually directly connected to the FA00 interface. We could do the same again, so we could create larger address space for the subnets. So this time we can see here it's still the same address space, but we now have a subnet created with 34.199.5, of which 72 is one of the addresses, and this relates to the IP address of FA0/0. The routing table isn't really interested in actual instances of IP addresses, it just needs to know how to get to certain destinations. Okay, so we can even go down to 40 if we wanted to subnet even more. Okay, so in this case we have this as an address, and we can work that out. If we bring our calculator up, should start in a little minute. Just takes a little minute to start up. So we see here we have 34.199.5.64. So the 72 address in binary is such as this. So we'll just use a notepad to sketch this out. Okay, so this is 72 at the end, and now our subnet mask 240 gives us 1111000. So we'll just check that. 240 in binary gives us 4 ones. 1, 2, 3, 4. 1, 2, 3, 3. So we then, wherever there's a 1, the network address comes through, so that becomes that, and whenever we have 0, we ignore it. So you can see here that what we end up with is that. So this is a 1, 2, 4, 8, 16, 32, 64. So you can see here that this equals 64, which gives us this subnet here. Okay, so let's try some sample examples. So in this case 1.2.3.4/24. This is a Class A address with a 24-bit mask for the network part, and the actual subnet it knows about is this one here, because we subnet for the first 3 digits. Same again for 2.3.4.5. So let's try this one. So these, in this case, this is a standard Class B address. Class B standard subnet is this. So our actual address of the network is this, and it's then been subnetted with the next field, which gives us the 10 here. This one over here is still a class B, but it has a standard class B subnet mask, so it hasn't been subnetted. This is why we get this here. For the third example, we have a class C address. For the class C address, we have a standard class C address, so it is direct connected with no subnets. With this, we have a class B with subnets. So the class B address is this, and the address that we know about is the one that's connected, and that's the 44.0 network. And then for the last one, we can see here we have a class C with a standard class C subnet mask. This time we have a class C address, and we have subnetted here. So again, it's a similar one to the last time. So in this case, we have 193 is this. So we'll just copy that. Okay, so we'll end up with this. We have the same subnet mask as before, but in this case we get 1100 and then ignore. So this now becomes 1, 2, 4, 8, 16, 32, a 64 plus a 128, which should give us 192. So the subnet itself is obviously 192.168.20.192, and the address of the port is .193 in this case. Okay, so this is a useful educational tool to be able to understand the subnetting and the entries in the routing table for directly connected network connections.